Hey everyone, in this recording we are going to complete the identity you see on your screen right now. So we have the difference of two fractions. The first fraction is sin x plus cosine x all over sin x, and the second fraction is cosine x minus sin x all over cosine x. So they do look quite similar, and while there's more than one way to go about doing a problem like this, I'm probably just going to show, I took some notes which way I wanted to do it. I'm probably just going to show you one way that I think is maybe most practical. I lie. I'm going to show you two. I'm going to show you two options. So one thing that, just as a heads up, you want to watch out for is you want to remember that minus sign is in front of a quantity. So when we get rid of that fraction aspect of it, there are implied parentheses around the fraction and mostly around the numerator. So we're going to have to distribute that negative, and it will become a plus when we get in front of this spot right over here. So that's the troublesome area. So let's look. So for option number one, what you want to do is, I like to look at it, my pretzel style over here. So I'm going to kind of reduce pretzel style. So you can only do this when the denominator is just one thing. If your fractions were flipped over, you couldn't do this upside down. This is not allowed. All right, so sin x over sin x, and if you've seen any of my other examples, I tend to switch from x to theta, just habit preference. So sin x over sin x is going to be 1 though, anything divided by itself, plus cosine over sine is cotangent using the quotient identity minus the quantity of. Cosine over cosine is 1, similar to the one right over here, and then minus sine over cosine, that's going to be tangent theta. In the next step, I'm going to open the parentheses now. So some people might try to do this all in one step, totally fine. 1 plus cotangent theta minus 1 plus tangent theta. 1 minus 1, adios, and you're left with cotangent theta plus tangent theta. So that is one way to look at this, but I believe they took it further, because I believe this one might be a multiple choice question, and I believe they took it further from here. And what they did was they didn't have it as a sum at all. The whole thing came together. So we kind of go back to where we started. So that's why, I wanted to give you options here. So we have cosine theta over sine theta, and that's being combined with addition with sine theta over cosine theta. If we want to add these two things, we need a com denom. So I'm going to multiply this first fraction on top and bottom by cosine theta, and I'm going to multiply my second fraction on top and bottom by sine theta. That means in my next step, I have cosine times cosine, which is cosine squared theta, plus sine times sine is sine squared theta, all over the common denominator of the product cosine theta, sine theta. Next, the numerator, I can apply the Pythagorean identity. So I know that that is equal to 1. And then I have cosine theta, sine theta in my denominator. Whenever we simplify, we try as best we can to get it down to a single trigonometric expression. If we can't get it down to a single trig expression, it might be a product, but we try not to keep anything in the denominator. So all we're going to do to finish this up is we're going to bring up cosine and bring up sine using reciprocal identities. So cosine on bottom is the same as secant on top, and sine on bottom is the same as cosecant on top. And we're a little squished, but there you have it. So that's definitely one way that we can go about doing it. I'm just looking to see if I did do it. Actually, the other way I did it ends up being just wider to write down. So the other way was I kind of found a common denominator right away. So I took this entire first fraction right away, multiplied on top and bottom by cosine, and this fraction on top and bottom by sine immediately. And instead of having the ones in the tangent and the cotangent, it's just like all sines and cosines, but the exact same thing, just a lot more to write. So I think this is good enough for now. If you need more practice, more examples, click through for the next one in this particular review set, or check the description box for more specific on this topic. I do have, a few links down underneath it. And if you feel good and you understand what you're doing, go on ahead and give the video a thumbs up. If you don't feel good and you hate it, hate me, hate the video, hate the example, go ahead and give the video thumbs down, whatever. Just feedback is appreciated. If you did it differently and you have a great idea, suggest it in the comments, and hope you're feeling smarter at this moment. Adios.